So remember when we talked about fractional values on the number line, we said the first thing that you need to do is you start at 0 and you count how many jumps it takes you to get to the 1. How many jumps it takes to get to the 1. So in this situation, it took us 6 jumps to get to it. The number of jumps represents your denominator. So here it was, 6 jumps. This one was 3 jumps. The one down below was 5 jumps. So it allows us to see what the fractional value is in between our whole numbers. Now remember, every time that we are between -1 and +1, those represent fractions that do not have any mixed number portions. So no whole number values are going to go there. Anything beyond the 1s up to the 2 mark are going to have whole numbers of 1 or -1s. Anything beyond the 2s up to the 3 marks are going to have whole numbers of 2 or -2, and so on and so forth. So we were talking about how to be able to label those correctly. And then you guys did your quiz yesterday. You guys did pretty well on the quiz, so I'm very proud of that. It went into the grade book. So what we're going to do now is we're going to finish off the rest of the notes by identifying values from least to greatest. Now remember, if they're written in this form, 2 to the 3rd power, I don't know how to rank that. I don't know how to rank 2 to the 3rd power, but I can solve 2 to the 3rd power and get a value that is rankable. So 2 to the 3rd power, who knows what it means when you've got an exponent? What is that telling us, Rajay? Yeah, it tells us how many times we're going to multiply our 2, our base, right? If it was 5 to the 3rd power, then we would be telling how many times we're multiplying the 5. So for here, 2 to the 3rd power, what this means is we are doing 2 times 2 times 2. We're doing it 3 different times. We're not saying that it's 2 times 3. 2 times 3 is not the same thing as 2 times 2 times 2. So we want to make sure we know how to properly identify that. So 2 times 2 times 2 is going to equal 8. So now I know that this value, 2 to the 3rd, is actually equal to 8. Then we've got a -1.8, and then we've got a -1.85. Then we've got a 4. Oh, now we've got a fraction. So remember, we don't like to compare them when they're in fraction form. So what do we convert it to? A decimal. So 2 and 4/6 is actually going to come out to 2.6 repeated. That 6 is going to keep repeating. So we're going to put a bar over the top. If you've got your computers opened up, go ahead and close them. Thank you. Patrick, go ahead and close yours, honey. Thank you. Okay, then we've got an absolute value of -2 and 1/3. Remember, absolute value is always going to be positive. Absolute value is always positive. So we know this is going to be 2.3, and the 3 is going to repeat. And then we have absolute value of 2.05, which again is just the positive 2.05. Okay, so now we've got all of our decimal versions. The next thing I want to do is I want to look and see what's the largest number of decimals, or largest number of place values I have behind the decimal. Okay, so here I don't have anything behind a decimal. Here I have one number behind a decimal. Here I have 2 numbers behind a decimal, and so on and so forth. So the most numbers I have behind a decimal are 2 values. So what I want to do is I want to make sure I have every one of these being 2 values behind a decimal. So that means with 8, I'm going to put 8.00. With -1.8, I'm going to put -1.80. I don't have to do anything with -1.85. For 4, I'm going to make it 4.00. With 2.6 repeated, am I going to put a 0 behind it? No, because it's 6 repeated. So what's going to go behind it? Another 6. Same thing with 2.3 repeated. I'm going to put a 3 behind it. Not another 6, because there wasn't a 6 that's repeating. It's a 3 that was repeating this time. And then 2.05. So now I have all of my numbers in decimal format. We just need to go ahead and place them in order from least to greatest. So do I have any negative numbers up here? Yeah, I do. I have a couple of negative numbers up here. So we want to focus on our negative values first because we know those are going to be our smallest. So here's a negative number, and here's a negative number. Which one of them is the furthest away from 0 on a number line? Negative 1.8 or negative 1.80 or negative 1.85? Coven? Negative 1.85. So there's our smallest value. This one is our smallest. So I'm going to even write up here, I'm going to circle it, and I'm going to put down that this is my first value. That's going to be my first number that I'm writing down when I put it in order from least to greatest. So that would be, in its original form, negative 1.85. Okay, that means that my second value is going to be the only other negative number that I have, negative 1.8. All right, do I have any zeros up here? No, so there's no zeros. So now we're just going to focus on positive numbers. All of these are positive numbers. Which one of these positive numbers is the smallest positive number? Noah? 2.05. So this is going to be my third value. This is going to be the third number. And remember, we're going to put it in its original format. We're going to put it in its original format. So that's going to be absolute value of 2.05. Okay, what's next? Rajay? 2.3333, right? The one that's repeating. So that's going to be right here. That's my fourth value. That's going to be the, again, in its original form, it's the absolute value of negative 2 1/3. All right, what comes next? Armand, what's our next value going to be? $2.666, right? It keeps repeating, right? That value that's going to keep going, that's our fifth value. But again, are we going to put 2.6 repeated? No. What are we going to write? We're going to write 2 4 6. We're going to write it in its original format, 2 4 6. All right, so then which one's the next smallest? 8 or 4? Brandon? 4, right? That's going to be our sixth value, which in its original format is just a 4. And then our last one is our seventh value. That's 2 to the third power, right? We always put them in their original format, their original form. And there's our order from least to greatest. Okay, so what we're going to do now is here we've got a problem. Josie is in the Key Club and has organized a pizza party. The club members sliced each pizza themselves before sharing it. So for pepperoni, we have 2/6 of the pizzas left over, slices left over. There's 2 out of 6 slices left over. For sausage, there's 0.25 slices left over. Out of Canadian bacon, there's 4/10 left over. For cheese, there's 3/8 left over. We want to know which pizza is the most popular. That means it has the least amount left over. It has the smallest amount left over. Which pizza is the least popular, which means it's going to have the most amount left over. So remember, this represents what's left over. If it's a good pizza, there's not going to be much left over. It's going to have a very small amount versus what's going to have a large amount. And then you're going to put the pizzas in order from least to greatest. You don't have to put the number values. You're going to need to use the number values, but you're going to tell me in order from least to greatest which one is the least popular, which means it has the most left over, to the most popular, which is the smallest amount left over. So if you're comparing it here, you're doing greatest to least when you're putting it in order. Okay? I want you to answer 1, 2, and 3 on your own. You can put it on your paper. Use your pencil. You don't have to use the colors. Okay? When you're doing it on your own, use your own pencil. First thing that we want to know, which pizza is the most popular? That means it has the least amount of leftovers. Which one was the most popular pizza? Addison? the sausage, right? If we take a look, 2 over 6, Jaden, quiet, 2 over 6, that converts to 0.3 repeated. That's 0.3 repeated. Sausage is already in its decimal form. We have 0.25. Okay, so that means, hey, I want to have the same number of decimals behind it, so I'm going to add another 3 here, just so I have the same number of decimals. Okay, Canadian bacon, that is going to be equal to 0.4. Okay, 0.4. Well, I want to have the same number, so I'm going to go ahead and put a 0 behind it. And then our last one, cheese, this converts to 0.375. Oh, well, I've got a third decimal, so what am I going to add behind this one? I'm going to add a 3, another 3 behind there. Behind the 2.5, I'm going to add a 0. Behind the 40, I'm going to add another 0 to make it a 400. So I'm going to make sure that I have the same number behind each of them, just so it makes it easier to compare. And again, the most popular pizza is the one that has the smallest amount left over, which happened to be the sausage pizza. So sausage was the most popular. What was the least popular pizza then? The least popular, Nihat? Canadian bacon. Who wants Canadian bacon on their pizza? That's like a breakfast item, not a pizza item. Okay? So Canadian bacon has the most left over. Jaden. Okay? Now from least popular to most popular. So that means from least popular to most popular, that basically means your greatest to least. When we're looking at these numbers, greatest number of slices left over, which is our least popular, that would be our, which one? Brandon?
Sausage.
No.
Least
popular, which means has the most left over. The bacon, the Canadian bacon.
Wait, can I see the other one?
Quiet.
Canadian bacon.
Hey. Okay, then it goes to cheese. Good. Cheese would be the next one. Then pepperoni, and then sausage. Good. All right, so we have Canadian bacon, cheese, then pepperoni, and then our sausage. Okay, so there's our order from least popular to most popular, or greatest number of slices left over to least number of slices left over. Now, some of you have not yet finished your Delta math from earlier. So you need to make sure the only people who are done with the Delta math, Coven, Tabina, Paris, Sophia, Giancarlos, and Addison. Those are the only ones who are done. The rest of you need to get on and finish the Delta math, and then you can get on to today's practice.